So when I graduated from MIT, I did what most other chemical engineers would do. I started a clothing company. And so, and I've spent the last decade obsessing about how we can use technology to optimize clothing for comfort and performance. And as you can imagine, we like to put numbers on clothes, like using NASA phase change materials to make dress shirts that can keep you 2.5 degrees cooler, or knitting a blazer in 72 minutes using 3D printing technologies, or making a AI heated jacket with 10 watts of heat. Now, we test all of this in the lab, and as an endurance athlete, I like to test these things out in the real world and really kind of push them to their limits. So I biked across the country from here in Boston to San Francisco in one of our polos to just test it in every climate. And I ran a 1:24 half marathon in one of our suits just to show how stretchy it was. And it turns out, though, that all of these products actually have another number: their carbon footprint. So the dress shirt I was wearing had a carbon footprint of 6 kilograms, the suit, 12 kilograms, and combined, that's about 60 miles worth of driving. And it turns out that all the clothing that all of us are wearing right now has a carbon footprint. So this was the view out of my hotel room in Shanghai on a manufacturing visit. And that's not fog, that's smog. And this was just an eye-changing moment. You know, when I thought of the heavy hitters of carbon emissions, I used to think of, coal-fired power plants, jet aircraft, cars, but it actually turns out that all of that is deeply embedded in the clothing that we make and buy. So this was a pretty pivotal moment for me. We had just succeeded in making the world's fastest blazer, and I wasn't sure how much faster we could take it. And at the same time, shouldn't I be applying my engineering efforts to a better cause? So I dove in deep, and I went to all the manufacturers and the factories, and I love going to them because that's where you get to see how things are really made. I love these meetings because you get designers, engineers, and developers all in a room together, and that's really where the real innovation happens. But I was shocked to find that 10% of global carbon emissions are decided right in that meeting. And everyone who's buying clothing is part of this decision-making process. So there's a couple of reasons that the clothing industry has just such a massive carbon footprint. First, we use a lot of coal and natural gas to turn raw materials into fabrics, and most of them are derived from petroleum. And then we use a lot of bunker fuel to ship them all across the world. The other thing is that clothing manufacturing is still a very manual process, and so we tend to favor far-off, distant, but cheaper labor markets over innovation in materials and manufacturing techniques. And then third, culturally, fast fashion has made it so that we love these short trends and product cycles, which leads to overconsumption and waste. But I get the common question from both creators and consumers: what can I do about this? So what I'd like to propose here is a playbook of insights that we had from lowering our own emissions and working with many other brands to figure out how we can make the biggest impact. It challenges our notion that the carbon footprint of clothing is difficult to measure, complicated to reduce, and costly to implement. And I hope they can be a tool for us to all to make and buy low-carbon clothing. So this is the greenhouse gas protocol. This is how the whole world decided that this is the best way to do carbon accounting. It breaks down our emissions into 3 areas. One is, what are the emissions of your office, for example? The second part is, what are the emissions from the energy that you buy? And then third, what are the emissions from your suppliers and your consumers? And while this looks very simple, it's actually quite complex. And what ends up happening is there's so many inputs in here, and it's made that way because it needs to be generalized for all industries, and it's also extremely granular. And so what happens is, for most product brands, most of your emissions are going to come from Scope 3 emissions, so from your suppliers and your consumers. And when we talk about Scope 1, 2, and 3 emissions, we get caught up with things like switching LED bulbs in our office and forgetting about the emissions at our suppliers. What ends up happening is a lot of times brands, because it's so complex and daunting, they actually outsource the carbon accounting process to expensive third-party consultants, and you lose the ability to just really understand your own supply chain. Or worse, you just don't measure at all. So it took my team and I 5 weeks just to come up with this one number for one dress shirt. And we had 182 other products that we needed to characterize, so we needed a scalable way. But it turns out there's another way to look at this, and that's to think of clothing more like calorie counting. Because the carbon emissions in clothing can actually be broken down much the same way that we think of fats, proteins, and carbs, right? Which account for the energy in food. But instead, we think about what are the materials, manufacturing, and shipping that account for the energy to make the product. Except here, there's no good fats or bad fats. It's just all bad carbon, and we're trying to drive this down as fast as possible. So my old thermodynamics professor used to say, you can break down any process into its materials and energy balances. So we did just that. So we like to think about this whole process as, how much energy did it take to make this material? How much energy are we spending, actually manufacturing the product, and then the energy that's spent moving it all around. Luckily, all the information we need is readily available right here on this fabric header, and this is what most designers are looking for when they're making a decision. It's got the composition, the density, the weight, the country of origin, and so we took all this readily available data, and then we made a predictive model that actually takes all this information and correlates it with emissions factors data. And the benefit of this was it was a game changer because we could make decisions in real time about whether we should use viscose or cotton, for example, to really look at the emissions of the final product. The other part was we started to build a pattern recognition, some intuition about where were the key areas that we can make an outsized impact. And we learned 3 in particular that I'd like to share with you here. And for some context, for clothing, about 75% of those emissions actually come from the materials themselves. And most of that material to date has switched over to a common type of plastic called polyester. And that's derived from petroleum. So one of the interesting things is that you can reduce your carbon emissions by 52% by switching from new polyester, which comes from crude oil, to recycled polyester. And the reason is because it takes a lot of energy to extract that crude oil from the ground and a lot of heat to actually turn that into the constituent materials that we use to make plastic. The other thing is that we were able to make this using 100% post-consumer recycled water bottles, but with durability and purity because we sourced the bottles actually from Japan, where there's a culture and infrastructure for sorting and separating clear plastic. The other thing that we found was that by switching from traditional cut and sew production to additive manufacturing techniques, we could reduce the materials consumption by 35%. And the way this works is, traditional cut and sew, you roll out some fabric and you cut a pattern out, but 1/3 of that fabric actually gets thrown away. But with additive manufacturing, it's kind of like 3D printing. This computerized knitting machine basically knits a product layer by layer using only the yarn that's needed, and you get a final garment ready to wear that comes out with virtually 0 yarn waste. The third big place that we found we could save emissions is by stopping air shipping. Air shipping is 9 times as much carbon emissions than sea shipping, and the reason is because it takes a lot of fuel to keep aircraft going high up in the air and flying fast, then floating and taking advantage of the currents. And in most markets and routes, this is only about 3 weeks longer in usual markets. So this is something that we just found we just have to switch because the carbon emissions from sea shipping it's just a nominal cost. So the question becomes, though, can low carbon clothing, is it going to be a luxury item, right? Is it going to have a green premium? And it can't be if it's to displace high carbon clothing at scale. But it actually turns out that good carbon accounting is actually good financial accounting. And the reason is because less energy and less materials equals less costs. And it actually becomes like a magnifying glass to actually find inefficiencies and cost savings rooted in physics that you won't find on a profit and loss statement. In fact, I like to think of these as these like carbon loopholes that we can take advantage of. And one of the things is, like, when you think about additive manufacturing, right? You're saving 35% of that material, so you're not paying for it. By going from air shipping to sea shipping, you usually save about 75% in the cost alone. And for brands that are seeking to go net zero with their emissions, the 8 to 10% premium for recycled materials actually can get recouped by the fact that you don't have to pay for carbon offsets, which are basically like basically investments or a voluntary tax for your carbon emissions. Okay, so now if this is cheap and easy to do, why aren't we doing this at scale? Well, actually, it's starting to be done in the footwear sector, but we have a long way to go in apparel. In 2012, Nike launched Flyknit, which is a technology that combined computerized knitting, recycled materials, and sea shipping to make a flagship product. And I thought this was the coolest thing. But now, a decade later, the cost of a shoe with the same technology, same materials and shipping is actually $49 at Zara. This is game-changing, and it's a good thing because here, good carbon behavior is equated to low cost and vice versa. So as a creator, I've realized that there's just this beauty in making physical products, but at the same time, a real tangible footprint associated with them. And I think that the solution is a two-player game where creators and consumers both play their part. So to creators, learn to think, speak, and count in carbon and build an intuition around it because your decisions at the earliest stages of product design have the biggest impact. And you have the ability and responsibility to make recycled materials and additive manufacturing into desirable products. And if you're an aspiring creator or you're in a different industry, this framework may still apply, you just have to switch the materials. To consumers, I would say demand that brands go net zero with their emissions because what gets measured gets improved. But also, ask them if they sea ship your products, and also always look at the content label before you buy. And if the death of the plastic straw is any indication of the power of consumer voices, it's true that it can really put a bug in the ear of designers and brands. So I hope with this simple, intuitive playbook that we can all make high-impact choices when it comes to making and buying low-carbon clothing. Thank you.